Alright, we're working on number 68 here. When you read inequalities, I suggest you read from the variable x is greater than or equal to negative 3 and x is less than 1. And for graphing inequalities, you're going to have a choice at this point of two symbols. You're either going to be able to use an open circle or you're going to use a closed circle. And I want to make a point about which one you use, and to me it's quite logical the way they've set this up. So addressing x is greater than or equal to negative 3. That means x could be 0, it could be negative 1, it could be negative 2. Is x, this blue line I'm shading in, is all of x. Could x be negative 3? Am I allowed to touch negative 3? Yes, x could be equal. It's greater than or equal to negative 3. So I'm going to use a closed dot on 3, and I can shade all the way up to it. Okay? So now let's start addressing x is less than 1. Okay? X is less than 1. X could be a negative 1. X could be 0. Is x allowed to be 1? It has to be less than 1. So I'm not allowed to actually touch the 1. So what we do is use an open circle there and just bring the line right up to our open circle. Okay? So that takes care of number 68. Then we'll also take a look at number 71. Slide this up. And here we have, again, I encourage you to read this from the variable. X is greater than or equal to 5. So x could be 7. It could actually be 8. This number line goes on forever. That's why the arrow is there. Okay. Excuse me. X could be 6. Is x allowed to touch the 5? Yes, x could be equal to 5. So we use a closed dot and we bring our line right to it. Actually, I'm supposed to make a bold arrow at the end here. Okay. Notice on the other ones, x was confined between these two values. But on this one, x continues forever in the positive direction. Okay. So let's take a look at another inequality. We're going to look at number 73 now. Place. And we have to solve this inequality before we can graph it. Okay, it's not solved because you've got y divided by 5, so we need to get rid of that 5. There's different ways to think about it, but I'm just going to address it basically the way it's written. And this 73 is kind of in my way right now, so I'm going to get rid of that. Good. Now, in order to have y all by itself, I need to get rid of the 5. The 5 is held there by division, so the opposite operation is multiplication. So I'm going to use parentheses to indicate that I'm multiplying. I'm going to multiply by 5, and if I do that on one side, I have to do that on the other, times 5. Okay? These 5, this is like 5 over 1, so I hope you see 5 goes into 5 once, 5 goes into 5 once. 1 times y is simply y. I'll write it here. The inequality sign stays as it is, and then 4 times 5 is 20. Okay, so we have y is greater than or equal to 20. So we'll put some values on our number line. I'll put our 20 in the middle. I tend to just use integers unless for some reason that's not sufficient. For instance, I could say 20, 25, 30, 35. This is up to me how I number it. But I want 20 in the middle since I'm focused on the number 20. Then this would be 19, 18, 17. And again, these number lines continue forever in each direction. Okay, y is greater than or equal to 20. That means I'm allowed to touch the 20. And I have to shade in this direction. Okay, and I am supposed to put an arrow on that because it goes forever. All right, we'll take a look at number 74. It's quite similar. I need to solve this inequality before I can graph it. I do not have x all by itself. There's a negative 5 here. I want to get rid of, well, actually the 74 won't be in my way for this. The negative 5 is held there by multiplication, so the opposite operation is division. I'm going to divide by negative 5, divide by negative 5. This cleans up right away. Negative 5 goes negative 5 once, so you have x. I'll write it down here. You have x. 60 divided by negative 5 is negative 12. And we just divided by a negative number. Right here, I divided by a negative 5. I divided by a negative 5. Whenever you multiply or divide by a negative number, you have to flip the inequality sign. So notice down here, I had to flip the inequality sign, and that's because I just divided by a negative number. All right. So now to graph it, we'll put our negative 12 in the middle. So let's see, here's our negative 12, negative 11, negative 10, and x is less than negative 12. So am I allowed to touch the negative 12? No, it can't be equal. So this just indicates I can get close, but I can't touch it. And then you shade it in this direction. Okay? And again, I'm supposed to have an arrow here. Alright, that takes, whoops, I really want this to touch there. Okay, that takes care of 74. And now we will take a look at 77. And 77, we're going to have to do a little bit more work to get this solved. Okay? When you're solving inequalities, to a large extent, you can treat them like regular equations. The only exception being, as we showed on the last one, if you multiply or divide by a negative number, you have to flip that inequality sign. Okay? So we'll see if that happens in this case. It doesn't always happen. So I need to get x by itself. I have x on each side. So I need to either get rid of the 5x or get rid of the negative 12x. But I cannot get rid of this stuff with it trapped inside the parentheses here. I have to get rid of the parentheses by distributing the negative 2 to each term. And that gives us, I'm going to have to cover up our line here for a bit. Okay, so that gives us negative 10x, and that, because that's negative 2 times 5x is negative 10x. Negative 2 times negative 16 is a positive 32. And on the other side, I'm just going to bring down everything we have. So our inequality sign at this point is greater than or equal to, and we have negative 12x plus 16. Okay. I'm going to get rid of the negative 12x. Again, at this point, you could get rid of negative 12x, get rid of 16, get rid of negative 10x, or get rid of 32. This first step really is up to you. And my preference is to get rid of the negative 12x because I'll end up with a positive 2x over here, and I like to have my variables positive if possible. So to get rid of this negative 12x, it's held there by addition or subtraction, so I simply use the opposite sign of negative 12x to get rid of it. And I have to do the same thing on each side. Then I just draw a line and bring everything down. That's a 0. I don't have to write it. We have 16 less than equal to 2x plus 32. And now I still have a choice. I could get rid of 32, get rid of 2x, or get rid of 16. But now it becomes a lot more clear that my best bet is to leave 16 alone. If I get rid of 16, I'm not going to be any closer to having x by itself. If I get rid of the 32, I'll be one step closer to having this x by itself. By the way, you don't have to get rid of the 32 first. I could also just get rid of the 2. But in general, it's a little bit more work to get rid of things that are multiplied or divided. It's easier to get rid of things that are added or subtracted. So in general, that's going to be your best first step. The problem with multiplication and division is to get, whenever you multiply or divide an algebraic equation, you have to multiply or divide everything on each side. So that's a bit more involved. Alright, so I'm going to get rid of this 32 with negative 32, negative 32, and then I just draw a line to see what I'm left with. That becomes 0. The 2x just drops down. Inequality drops down. And positive 16, negative 32, negative 16. And one more step now. To get rid of this 2, it's held by multiplication. I'll use division. Starting to run off our page here. And 2 goes into 2 once. So you end up with, I'm going to write it over here. Well, I'll do it twice. You end up with x is greater than or equal to negative 8. So that's our solution. And I want to graph it on a line up here. So I'm going to, so 77, we figured out that x is greater than or equal to negative 8. So I'll put my negative 8 in the middle, negative 7, negative 6, negative 9, negative 10, and x is greater than or equal to negative 8. I should start from here. And so that means I'm allowed to touch the negative 8, but x is all the values that are greater than that. So I shade going in off to the right and put my arrow there.